everybody can look this up and everybody can remember degrees of freedom. Now, was there one that wasn't there? No, not yet. Okay. All right. Okay, let's go on. All right, this guy, you had to find your margin of error. Now, how did I know from this example that this is going to be a T one, not a Z? S. And what is the difference between sample standard deviation and population? Right, because if you know your population, you can use, I'm probably not reading the question right. If you know your population, you can use a Z-score. If you only know your sample, you have to use a T-score. A T gives you a slightly wider margin so that you can have just a little bit, a slightly larger margin of error, so it gives you a wider confidence interval. Because you're depending on your sample to be a sound sample and a good representation of your population, so it gives you slightly a little bit more to work with. And again, this one here also had the sample. So remember, you're looking up your T-score, and your N is still your sample size, it's still your N. Okay? All right. 7, 9. 9. Had you do the interval. Now, it's okay with me if you use your calculator. If you use your calculator and you have to give me the margin of error, then work backwards. Take one of the endpoints and subtract your mean from it so that you can give me the margin of error. Everybody comfortable with the calculator? If you don't find your margin of error formula, you can find it off your calculator by subtracting your mean. Okay. Did I give you number 12? Yep, number 12. Same thing. Oh, here was the one. This one wasn't in your table. So according to the book, it says my degrees of freedom should be 49, but that's not in your table. It said take the one right before it. So you should take 45. It's not a big difference between these. You should take this one and use it. If you use your calculator is a little bit more exact for it, so these are going to vary just a little bit. And I'm okay with when they vary, just show me what you use, because each one gives us a slightly different answer. No, it actually goes a little higher, but they go by fives. And if you look at your chart on page A18, God bless you. Let me see what it goes up to exactly. They actually changed this on ours. It goes up to 1,000, but at 40, it goes to 40, then it goes to 45, 50, then it goes to 60, 70. It jumps. So we've got a little bit of play in there. Okay, can everybody find 14 and 15? Can everybody find a mean and a margin of error given an interval? Yes? Okay. So it looks like it's pretty good. 19, you had to go use a sample of 13 microwaves, and the mean repair cost was $80, and the standard deviation was $13.50. How did you know this is a T-score? There's no population. When they start their sentence within a sample, whatever comes after it in that sample is the sample information. So this is the sample mean, this is the sample standard deviation. Okay, and the top of all this, the directions on the top set to assume all your distributions were normally distributed. So we were okay with that because it did say it at the top. So you find your interval. Now, remember what this means. The T-score works the same as the Z-score. You want to be 95% confident, because the original direction said find a 95% interval, that the population mean repair cost of microwave ovens will fall between these two. this is what you're looking at. This is where your population mean falls. You want to be 95% confident. You want to be able to say with a confidence level of 95% that you will find the population mean repair costs of microwave ovens between those two intervals. This is the inference that you make about the population based on what you just found out about your sample. Make sure you understand how to say it, how to interpret it. Because if you don't, you miss the whole point of doing this. We're making an inference about this. Okay? 21. 21 said use the information from 17, but I didn't give you the information from 17, so I quickly did it here. The only difference in 17, and this is worth noting, that in 17 we had a sample standard deviation. So we had to use a t interval. Now, in this one, they gave us a population standard deviation. They said, from previous studies, surveys, whatever, we know our population standard deviation. Now you're going to use a z-score. However, because they do this, they change the standard deviation. So you really, really can't tell the difference in the interval. But you can tell the difference right here. See the difference between, and this is the part that I want you to notice. See the difference between your TC and your ZC? Which one is larger? TC. So technically, if everything else stayed the same, if my population standard deviation was 7.2, so I'm going to redo this with the 7.2. Say they actually did find that that was true. And we put this in our calculator. This margin of error, let's just put this in real fast. This margin of error would be slightly smaller. Now you're going to be able to see the difference in this. Let me just multiply this. They should have kept everything the same. So 4.99. See the difference? See your margin of error be smaller? So what will happen to your interval for the population? How will it compare to the sample one? If your margin of error is smaller, what happens to your interval? It gets narrower. Thank you. It gets narrower. You see why? You really can't see why in their example because they obviously had to change the population standard deviation, but they kind of didn't show you what you needed to see. Because what happens now is your TC versus your ZC is smaller for the same exact 95%. If you multiply by a larger number, you should get a larger result, right? A larger margin of error makes your confidence interval wider. So we should see this guy getting narrower when we use the z-score, but we didn't because there was not really a correlation between those two. I didn't care for the way they did that example, but I guess they have to change it for population. All right, 22 said use what you found in 18, which you didn't do 18 either. So 18 gives us a TC for this. And again, we can see the difference here. They use the sample standard deviation. Here they use the population standard deviation, almost the same. A little bit smaller, but almost the same. So now you could see a little bit more difference in your margin of error. This one was a lot closer. A lot closer. So do you see your confidence interval for your T is wider? And I want you to write this on your paper. And we all remember how to use the words narrow and wider, not bigger, smaller. Your margin of error increases or decreases, gets larger or smaller, but your confidence interval widens or narrows. So that one had a little bit better of a correlation there. All right. Moving right along here. 23. You repeated the example in 19 again, and you found their standard deviation. Everybody use the calculator, the T interval? Yes? Okay. The last one, this is a great calculator problem because once you put this in your table, when you go to your T interval, that's when you use your data, not the stats. So when you go to data, you'll see where it says your L1. If that's where you put your information, you leave L1. If you didn't put it in L1, you put it in whatever table you used. But it'll calculate the mean. It'll calculate the sample standard deviation. It calculates everything else for you. The TC does everything. It just gives you one final answer. And from this, you can take your mean, because it'll show it to you when it comes back, and subtract it off that and find your margin of error. Any questions?